In the skies above, a world at war, it was known simply as the Jug. Weighing nearly 4 tons fully loaded, the Republic P-47 Thunderbolt was a beast among fighters, the largest, heaviest single-engine piston fighter aircraft ever to see combat. What began as an ambitious aeronautical challenge in the late 1930s would evolve into one of the most versatile combat aircraft in American history. The story begins in the Farmingdale factory of Republic Aviation on Long Island, New York. Alexander Kartveli, Republic's chief engineer, had been working on a lightweight interceptor design when the war clouds gathering over Europe changed everything. By 1940, combat reports from the Royal Air Force made it clear that America needed something different, something with greater range, superior firepower, and unprecedented durability. Kartveli scrapped his initial lightweight fighter concept. Instead of compromise, he embraced extremes. Why build a small fighter when you could build a juggernaut? The result was the P-47B, a design that broke nearly every convention of fighter aircraft development. When we first saw the blueprints, many of us thought it couldn't possibly fly, recalled one Republic engineer. It was simply too big, too heavy. But Kartveli understood something fundamental about air combat that others didn't. Power changes everything. At the heart of this revolutionary design was Pratt & Whitney's R2800 double wasp engine, an 18-cylinder radial power plant producing over 2,000 horsepower. But raw power wasn't enough. To maintain performance at high altitude, where bomber escorts would be desperately needed, Kartveli incorporated a complex turbocharger system tucked behind the cockpit and feeding through an intricate ducting system that ran the length of the fuselage. This turbocharger, manufactured by General Electric, was a marvel of engineering. Unlike some fighters that lost power as they climbed, the P-47's massive engine could maintain its output above 30,000 feet, where the air was thin, but critical bomber formations would fly. The turbocharger system created unique challenges. Exhaust from the engine was channeled back through the bottom of the fuselage to drive the turbine wheel. After compression, the now pressurized air traveled back through an intercooler before reaching the engine. This complex arrangement created the Thunderbolt's distinctive silhouette, a deep fuselage with a relatively small wing area for an aircraft of its size. You couldn't ignore the size, remembered one test pilot. Climbing into the cockpit felt like mounting a small locomotive. The instrument panel stretched wide before you, and when you looked over the massive nose, it seemed to extend forever. The prototype XP-47B first took flight on May 6, 1941, at Republic's airfield. The sound was distinctive, a deep-throated roar, unlike the higher-pitched notes of smaller fighters. Ground observers were struck by the sheer mass of the aircraft as it thundered down the runway. The aircraft's dimensions told the story: a wingspan of 40 feet 9 inches, a length of 36 feet, and a height of nearly 15 feet. Empty, it weighed 950 pounds. When later variants were fully loaded for combat, they'd tip the scales at over 17,500 pounds. By comparison, the iconic German Messerschmitt Bf 109 weighed just 5,800 pounds. Production challenges were immediate and significant. The P-47's size required manufacturing techniques more common to bomber production than fighters. Each aircraft contained approximately 16 Suezerrand rivets and 900 pounds of armor plate. The complex ducting system for the turbocharger required precision metalwork, and the 850 caliber machine guns, 4 mounted in each wing, needed precise alignment. Early test flights revealed both strengths and weaknesses. The P-47 could dive faster than any fighter in the inventory, occasionally exceeding 500 miles per hour, speeds that required reinforced control surfaces and careful pilot technique. Its roll rate was surprisingly good for such a large aircraft, though its initial climb performance left something to be desired. It wasn't love at first sight for many pilots, noted Colonel Hubert "Hub" Zemke, who would later lead the famous 56th Fighter Group equipped with Thunderbolts. Coming from P-40s, the size was intimidating. The cockpit visibility over that enormous radial engine cowling took getting used to. But the first time you unleashed all 8 50s on a target, you understood what this machine was built for. By early 1943, the first combat-ready P-47s arrived in England with the 56th Fighter Group. Their arrival was met with some skepticism from RAF pilots flying nimble Spitfires, who dubbed the oversized American fighter the unintentional dive bomber and the Jug, short for Juggernaut, though the nickname would become an affectionate one among American pilots. The early operational challenges were significant. With its initial limited fuel capacity, the first Thunderbolts could escort bombers only part way to targets in Germany. Engine management required careful attention to prevent overheating. The turbocharger system, while brilliant in design, demanded meticulous maintenance. Ground crews worked tirelessly in the damp conditions of East Anglia. Mechanics became experts at turbocharger maintenance, developing specialized tools and techniques not found in any manual. The P-47's appetite for spare parts soon established unique supply chains, from American factories to forward bases. The initial P-47C and early P-47D variants had a distinctive razorback canopy configuration with a tall spine behind the pilot, limiting rearward visibility. Pilots developed habit patterns of weaving in flight to check their 6 o'clock position. By spring 1943, they would need this vigilance as the Thunderbolts ventured deeper into hostile airspace. The first combat missions were revealing, wrote one pilot in his mission log. We'd been told the Jug could absorb punishment, but seeing a ship return with 3 feet of wing missing and still flying level, that's when we knew this was something special. As Allied bombing missions intensified in 1943, the need for the P-47 became critical. Boeing B-17s and consolidated B-24s were suffering unsustainable losses without fighter escort. The P-47, despite its initial range limitations, began to prove its worth. Its high-altitude performance meant it could stay with the bombers where other fighters struggled for power. The stage was set for the Thunderbolt to make its mark. Republic Aviation ramped up production, eventually manufacturing P-47s at the incredible rate of 1 per hour. Engineers worked continuously on improvements, additional fuel capacity, paddle blade propellers for better climb performance, and eventually a bubble canopy for improved visibility. By late 1943, the distinctive sound of Thunderbolts taking off en masse from English airfields had become a daily occurrence. The largest American fighter was about to demonstrate just how effective its combination of firepower, durability, and high-altitude performance could be against the Luftwaffe's best. As the winter of 1943 descended upon Europe, the stage was set for the great aerial battles that would determine the outcome of the strategic bombing campaign. For the men flying the massive Republic fighter, the real test was just beginning. The Thunderbolt was about to earn its reputation as one of the most formidable combat aircraft ever to take to the skies. The arrival of the P-47 Thunderbolt over European skies in early 1943 coincided with a critical period of the Allied air campaign. As daylight bombing raids pushed deeper into Nazi-occupied territory, the need for capable escort fighters became increasingly apparent. When the 56th Fighter Group touched down at RAF King's Cliff in January 1943, few could have predicted the impact these massive fighters and their pilots would have on the air war. Colonel Hubert "Hub" Zemke, commanding the 56th, faced an immediate challenge, transforming his group into an effective combat unit with an untested aircraft. The Wolfpack, as they would come to be known, developed tactics that played to the Thunderbolt's strengths. "We learned quickly that altitude was our friend," recalled Lieutenant Robert S. Johnson, who would become one of America's leading aces. The P-47 could outdive anything the Germans had, and at 30 feet, we had performance advantages that shocked Luftwaffe pilots. Early escort missions revealed both strengths and limitations. The Thunderbolt's initial combat radius of approximately 175 miles meant bombers were vulnerable during the deepest parts of their missions. The 56th and other P-47 groups would take bombers part of the way, then reluctantly turn back as fuel reserves diminished, often watching helplessly as German interceptors swarmed the unprotected formations. This painful reality drove rapid development of external fuel tanks, eventually extending the fighter's range dramatically. When contact was made with enemy aircraft, the P-47's 8 50-caliber Browning machine guns demonstrated devastating effect. Each gun could fire 800 rounds per minute, creating a combined rate of fire that could deliver over 100 pounds of bullets in a 3-second burst. Ground crews nicknamed these guns sledgehammers for their ability to shatter German aircraft. The weight of this firepower, over 400 pounds for guns and ammunition, was something only the massive Thunderbolt could practically carry. "When you hit something with 850s, it stayed hit," explained Captain Frederick "Freddy" Christensen of the 56th. "We'd come back with gun camera footage showing parts literally being torn from 109s and 190s. The concentrated firepower proved particularly effective against the sturdy Focke-Wulf 190, which could otherwise absorb significant damage." At altitudes above 25,000 feet, where B-17 and B-24 bombers typically operated, the Thunderbolt's powerful R-2800 engine and turbo supercharger combination provided a critical edge. German fighters, particularly the Bf-109, suffered performance degradation at these heights. P-47 pilots learned to use this advantage, climbing above enemy formations before diving through them, using the fighter's exceptional speed in a dive, sometimes exceeding 550 meters patent, to make slashing attacks before climbing back to safety. The harsh realities of combat operations in the European theater demanded continuous innovation from both pilots and ground personnel. Maintaining the complex P-47 presented unique challenges. The turbo supercharger system, essential for high-altitude performance, required particular attention. Technical Sergeant Walter Grubb, a crew chief with the 78th Fighter Group, recalled, "The supercharger regulators needed constant adjustment. We'd work through the night in freezing conditions, fingers numb, making sure every aircraft was ready at dawn. The pilot's life depended on getting it right." By mid-1943, the Battle of the Ruhr and operations against German industry were intensifying. On April 17th, P-47s escorted bombers to Bremen, engaging in fierce combat with defending fighters. The Thunderbolt's diving ability and firepower proved decisive in these encounters, though pilots were still learning to compensate for the aircraft's less impressive climbing rate and turn radius compared to nimbler German fighters. The infamous Schweinfurt-Regensburg mission of August 17, 1943, highlighted both the importance and limitations of fighter escort. P-47s could only accompany the bombers for part of their journey, and the results were catastrophic. 60 B-17s lost and many more damaged. This painful lesson accelerated the development of drop tanks that would eventually allow Thunderbolts to reach Berlin. As combat experience accumulated, pilots developed distinctive tactics. The 56th Fighter Group under Zemke became particularly adept at the Zemke fan, a formation that spread fighters at different altitudes to maximize coverage while allowing mutual support. This approach played to the P-47's strengths, enabling pilots to dive on targets and climb back to safety. The Thunderbolt began proving itself as an ace maker. By early 1944, pilots like Francis Gabreski, Robert Johnson, and David Schilling were accumulating impressive victory totals. Johnson's experiences highlighted the aircraft's legendary durability. On one mission, his P-47 absorbed over 200 machine gun and cannon hits, yet returned him safely to base, a testament to the rugged construction and self-sealing fuel tanks. The cockpit was armored, the engine was practically bulletproof, and you sat behind a massive radial engine, Johnson later wrote. Flying the Thunderbolt gave you confidence that you could take punishment and still make it home. Maintenance crews developed innovative field modifications to improve performance. Propeller cuffs were adjusted to improve climb rates, engine cowlings were tightened to reduce drag, and various paint schemes were tested to reduce visibility. Some groups even experimented with polishing the aircraft to gain a few extra miles per hour, crucial in combat, where speed advantages of just 10–15 mph could mean the difference between victory and defeat. Armourers faced their own challenges with the massive battery of 8 machine guns. Technical Sergeant Ray Wilkins of the 353rd Fighter Group explained, "Each gun had to be precisely harmonized. We'd set them to converge at about 300 yards, the sweet spot for accuracy without sacrificing pattern density. It took hours of precise work." As 1943 progressed into 1944, P-47 groups began developing coordination with bomber units that dramatically increased effectiveness. Radio discipline, formation tactics, and timing improved, allowing for smoother handoffs between escort groups and better protection throughout missions. The 8th Air Force developed a relay system where different fighter groups would protect bombers during specific legs of their journey, maximizing coverage with available aircraft. The air battles over Bremen, Schweinfurt, and other strategic targets became increasingly sophisticated as both sides adapted. Luftwaffe tactics evolved to focus on bomber formations before and after fighter escort was present. In response, P-47 groups began employing freelance fighters, aircraft released from close escort to seek out and engage German fighters forming up to attack bombers. By early 1944, P-47 pilots had accumulated significant combat experience and confidence. Their record against the Luftwaffe's best was impressive, not because the Thunderbolt could outmaneuver German fighters, but because American pilots learned to leverage their aircraft's strengths while minimizing its vulnerabilities. The combination of high-altitude performance, devastating firepower, and remarkable durability made the P-47 an increasingly feared opponent in European skies. As spring approached, however, the Thunderbolt would find itself evolving toward a new role that would ultimately cement its legacy as one of the most versatile and effective aircraft of the war. The coming invasion of Europe would demand air support of a different kind, and the massive fighter was about to demonstrate capabilities few had initially imagined possible. As Allied forces pushed deeper into Europe following the success of D-Day, the role of the P-47 Thunderbolt underwent a dramatic transformation. What had begun as a high-altitude interceptor and bomber escort would become one of the most devastating ground attack aircraft of World War II. By mid-1944, Republic aviation engineers had been working tirelessly to adapt the massive fighter to its expanding mission profile. The addition of bomb and rocket hardpoints beneath the Thunderbolt's wings marked a critical evolution in its combat capability. These modifications weren't merely afterthoughts, they represented a fundamental shift in tactical doctrine. The P-47D variant, which would become the most numerous of all Thunderbolt models, featured strengthened wings capable of carrying up to 2 500-pounds of bombs or 10 5-inch rockets. "We started calling her the Flying Dump Truck," recalled Lieutenant James Reynolds of the 362nd Fighter Group. "One day, you're dogfighting Me-109s at 30,000 feet. The next, you're hedge-hopping with 1,000 pounds of high explosive under each wing. The Jug could do it all. The aircraft's transition to ground attack coincided perfectly with the Allied need for close air support following the Normandy landings. As American, British and Canadian forces pushed inland from the beaches, they faced determined German resistance, particularly from armoured units. P-47 squadrons quickly adapted to the challenge. The Thunderbolt's 850 caliber machine guns, already devastating against aircraft, proved equally lethal against ground targets. A typical strafing run from a P-47 could deliver approximately 100 rounds per second, capable of penetrating the engine compartments and fuel tanks of German tanks, and utterly devastating against soft-skinned vehicles and infantry positions. What pilots called juggernaut diplomacy became a nightmare for German forces attempting to move during daylight hours. The 9th Air Force alone, with its substantial P-47 contingent, claimed the destruction of over 6 German tanks and armoured vehicles between D-Day and VE Day. Colonel Harold Johnson of the 8th Fighter Command explained the philosophy. We aim to make daylight movement of any kind suicidal for the Germans. If it rolled, flew, or floated, the Thunderbolts would hit it. The P-47's ground attack tactics evolved quickly through battlefield experience. Skip bombing, where bombs were bounced along the ground into targets, became a specialty of many Thunderbolt pilots. The technique allowed for greater accuracy against hardened targets like bunkers and bridges, while minimizing exposure to anti-aircraft fire. Rocket attacks presented another dimension of the P-47's evolving arsenal. The M84. 5-inch rockets, while less accurate than direct bombing, delivered devastating concussive force against concentrations of enemy vehicles and troops. Pilots developed a technique of shallow diving from 2,000 feet, releasing rockets at approximately 1,000 feet, then pulling up sharply to avoid ground fire. You'd come in hot and low, find your target through all that mud and smoke, let those rockets go, and then get the hell out of there, and described Captain Thomas Webster, a veteran of the 366th Fighter Group. The Germans would be throwing everything they had at you. Small arms, 20mm 88s, if they had them nearby. The Jug took hits that would have dropped any other fighter. Indeed, the P-47's legendary ruggedness proved vital in its ground attack role. The massive radial engine could continue running, even with several cylinders damaged. The cockpit's heavy armor plating protected pilots from ground fire, while the robust airframe could absorb significant battle damage and return home safely. Tech Sergeant William Harmon, a P-47 crew chief with the 78th Fighter Group, recalled, "We'd count the holes after each mission, 30, 40 holes sometimes. Hydraulic lines shot through, control surfaces tattered, but she'd still bring our boys home. We'd patch her up overnight and she'd fly again the next morning." The logistical challenges of supporting P-47 operations from forward air bases were substantial. Each Thunderbolt consumed approximately 300 gallons of high-octane aviation fuel per mission, about twice what a P-51 Mustang required. The massive R-2800 engine demanded rigorous maintenance schedules, with oil changes every 25-30 flight hours and spark plug replacements every 50 hours. Armorers worked around the clock to load the Thunderbolt's hungry machine guns. A full ammunition load consisted of 3 400 rounds, over 425 rounds per gun, weighing nearly 900 pounds. Bomb loading required specialized equipment to hoist the 501 000-pound bombs onto the underwing hardpoints. As the Allied armies advanced through France and into Germany, P-47 units followed closely behind. Advanced landing grounds, often nothing more than hastily graded farm fields, became temporary homes for Thunderbolt squadrons. This forward deployment allowed for rapid response to battlefield developments and maximum time over target areas. The statistics of the P-47's ground attack campaign tell a story of industrial-scale destruction. From June 1944 through May 1945, Thunderbolts flew over 90 Udre-0 sorties over northwestern Europe. They dropped more than 60,000 tons of bombs, fired over 125,000 rockets, and expended approximately 135 million rounds of 50 caliber ammunition. The 12th and 9th Air Forces recorded the destruction of over 86,000 German vehicles, 9,000 locomotives, 6,000 armored vehicles, and uncounted artillery positions. The human cost of this campaign was also substantial. The 9th Air Force alone lost over 800 aircraft during the European campaign, with the P-47 squadrons suffering heavily due to their low-altitude operations. German flak defenses remained lethal until the final days of the war. By early 1945, the P-47's ground attack role had evolved to include specialized interdiction missions targeting the German transportation network. Railroad marshalling yards, bridges, tunnels, and canals became priority targets as Allied commanders sought to completely isolate German military units from their supply chains. The strategic impact of the Thunderbolt's ground attack campaign extended far beyond tactical victories. German field commanders reported the inability to move troops or supplies during daylight hours, forcing night marches that exhausted infantry and consumed precious fuel reserves. Armor units were compelled to disperse and camouflage their vehicles, making coordinated counterattacks virtually impossible. As Allied armies pushed toward the Rhine River in early 1945, P-47 pilots developed close working relationships with forward ground controllers. These specialists, often operating just behind frontline units, could direct Thunderbolts precisely onto enemy strong points, impeding the Allied advance. As the European theater of operations entered its final stages, the P-47 Thunderbolt was about to face an entirely new challenge. Deployed to the vast reaches of the Pacific, the massive fighter arrived in a theater dominated by lighter, more nimble aircraft like the P-38 Lightning and carrier-based Navy fighters. Yet the Thunderbolt would once again prove its exceptional adaptability. The first P-47s reached the Southwest Pacific in mid-1943, initially with the 348th Fighter Group. The jungle airfields presented immediate challenges. The heavy Thunderbolt required longer, more substantial runways than the coral and dirt strips hastily carved from dense vegetation. Ground crews worked around the clock, extending runways and reinforcing surfaces to accommodate the 7-ton fighter. "We had to completely rethink our airfield construction," recalled one Army engineer stationed on New Guinea. "What worked for a P-40 wouldn't necessarily work for a Jug. We learned that the hard way when one sank halfway to its wings on a rain-soaked strip. Mechanical challenges emerged unique to tropical operations. The P-47's complex turbocharger system, so effective at high altitudes over Europe, required additional maintenance in the humid, salt-laden air of the Pacific. Corrosion became an ever-present enemy. Ground crews developed new procedures, including more frequent inspections and application of protective compounds to sensitive components. Despite these challenges, the P-47's ruggedness proved invaluable. The 5th Air Force commander, General George Kenney, initially skeptical of the bulky fighter, became one of its strongest advocates after witnessing its ability to absorb battle damage and return pilots safely. The dense jungle below meant any mechanical failure could result in pilots disappearing without trace. The Thunderbolt's reliability literally meant the difference between life and death. Operating from bases in New Guinea, the Philippines, and eventually Okinawa, P-47 pilots adapted European tactics to Pacific realities. The fighter's tremendous range limitations, a significant concern in Europe, became even more critical over the vast Pacific. Engineers modified the aircraft with additional fuel tanks, eventually allowing missions extending beyond 1,000 miles. While the P-47 never reached the fame of the P-38 Lightning in the Pacific, its ground attack capabilities proved devastating against Japanese installations and shipping. An 5th Air Force Squadron reported destroying over 50 vessels in a 3-month period through skip bombing techniques, where pilots would release bombs at low altitude to bounce across water into ship hulls. The difference between European and Pacific operations became apparent in pilot accounts. In Europe, you worried about Me-109s jumping you from above, wrote Captain Daniel Garrett of the 348th Fighter Group. In the Pacific, you worried about your navigation, about finding that tiny island runway after hours over empty ocean. The Jug didn't have the range of the Lightning, but it could take a beating from ground fire that would have cut a P-38 in half. As the war progressed, Republic Aviation continued refining their heavyweight champion. The P-47M variant, introduced in December 1944, featured a more powerful R-2857 engine, producing an astonishing 800 horsepower, pushing top speeds beyond 470 mph. Though primarily deployed to counter Germany's jet and rocket-powered aircraft, a small number saw service in the Pacific. The definitive Pacific variant emerged as the P-47N, specifically designed for the extremely long-range missions anticipated for the invasion of Japan. With its distinctive squared-off wingtips, strengthened wing structure, and unprecedented internal fuel capacity, the N model could escort B-29 superfortresses on their grueling missions to the Japanese home islands from bases like Iwo Jima. Lieutenant Colonel William Dunham, who flew both late-model P-47s and captured Japanese fighters for evaluation, noted, "The Japanese had nothing that could match the N-model Jug above 20,000 feet. It was faster, better armed, and could outclimb anything they had. Most importantly, it could take punishment that would have destroyed any Japanese fighter instantly." Republic Aviation's production capacity reached staggering levels. From the Farmingdale plant on Long Island and the massive government-owned facility in Evansville, Indiana, P-47s emerged at the rate of one every hour at peak production. By war's end, 15 636 Thunderbolts had been manufactured, a testament to American industrial might. This made it the most numerous American fighter aircraft produced during the war, a fact often overlooked in popular history. The conflict's end didn't mean retirement for the Thunderbolt. While the U.S. Army Air Force quickly transitioned to jet aircraft, many Allied nations embraced surplus P-47s. The Brazilian Air Force operated Thunderbolts until 1954. The French deployed them extensively in Indochina. The Chinese nationalist forces flew them during their struggle against communist forces. The Thunderbolt's influence extended far beyond its operational life. Republic Aviation's experience with the P-47 directly influenced their F-84 Thunderjet and F-105 Thunderchief, both of which inherited the Jug's philosophy of ruggedness and firepower. Elements of the P-47's design thinking would echo through American fighter development for decades. Today, approximately 24 P-47 Thunderbolts survive in museums and private collections worldwide. A handful remain airworthy, thrilling airshow crowds with the unmistakable sound of the R-2800 engine at full power. These flying examples require extraordinary maintenance, with specialized teams of mechanics preserving the technical knowledge necessary to keep these complex machines operational. At the National Museum of the United States Air Force in Dayton, Ohio, a perfectly restored P-47D stands testament to American engineering prowess. Its massive propeller and imposing silhouette still command attention, even surrounded by sleeker, more modern designs. Each surviving Thunderbolt represents not just an aircraft, but the culmination of American industrial capacity, engineering innovation, and the skilled pilots and ground crews who operated them under the most demanding conditions. The P-47 Thunderbolt remains somewhat overshadowed in popular memory by more glamorous fighters like the P-51 Mustang. Yet for those who flew it into combat, maintained it under field conditions, or designed improvements during its evolution, the Thunderbolt represents the epitome of American wartime achievement, a seemingly impossible combination of speed, firepower, and durability that helped secure victory in two theaters of war. In the words of one veteran P-47 crew chief, "They don't make 'em like that anymore, and truthfully, they couldn't if they tried."